Hello and welcome to the night class. Today we're going to be learning a little trigonometry, a little continuation of trig. I'm Coach Knight. We're going to talk about the trigonometric ratios along with some other fun stuff. So let's get right to it. So the first thing you need to know is a couple of definitions here. We have the hypotenuse and the legs, and that is simply referring to the triangles. And it has to be a right triangle, okay? So if it's not a right triangle, this doesn't matter. There is no hypotenuse if it's not a right triangle. So on the right triangle, you have the hypotenuse is always the side opposite the right angle, okay? And then you have the legs, which are the other two sides of the triangle that make up the right angle, okay? So the two sides that are making the right angle are the legs. The hypotenuse is the longest side that is always opposite the right angle. We have what's known as the side that's adjacent and the side that's opposite. So this all depends on what angle you're talking about. So in this case, we're looking at this angle right here. That's theta, okay? So this angle, this side would be opposite, and this side is adjacent, okay? So I'll do that one more time. Let me highlight them. How about that? This side would be opposite because it is not touching the angle. And this side right here would be adjacent because it is touching the angle. Adjacent just means that it's next to. So if you've never heard of sine, cosine, and tangent, here they are. They are simply ratios, which is a fancy word for fraction. And here's how you find them. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Now, when they talk about that, they are, of course, talking about the opposite leg or the opposite side. Adjacent leg, adjacent side, same thing, okay? So sine, cosine, tangent. A lot of people have come up with the term SOHCAHTOA to help remember what is what. So sine is opposite over hypotenuse, and then cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So all three of those help you to figure out each trig ratio. Another little helpful rhyme or whatever, a lot of people they say some old hippie caught another hippie tripping on acid. So that's another way of remembering SOHCAHTOA. So I suggest write it down every time when you're working the problems, and by the time you are ready to do it on your own, on a test, you will have them memorized. So you do need to memorize them though. So we're going to find example 1, start here. It says find the values of the sine, cosine, and tangent for P. So angle P is right there. So we're going to see here, find the sine of P and the cosine of P and the tangent of P. So sine, again, is opposite over hypotenuse. Well, the opposite side from P is 3. And the adjacent side, the hypotenuse would be 5. So 3 over 5. The cosine of P is adjacent over hypotenuse. I don't know why there was a line through there. So adjacent over hypotenuse, the side that's adjacent to P is this side right here. So that's 4. And again, like we said, the hypotenuse is 5. 4 over 5. And again, you always reduce if you can, but sometimes you can't. For the tangent of P, we're going to do the side opposite P, which would be 3. Opposite over adjacent. So 3 over the adjacent side, we've already said, is 4. 3/4, which you cannot reduce that either. So that's it. That's how you find the sine, cosine, and tangent. Example 2 gets a little harder. Notice they didn't give us all three sides, so we actually have to find the side. And so this is side A. I know it's side A because it's opposite angle A. The sides are always named the same as the angle that they're opposite. So before we can do any of this, we need to find the third sine using good old Pythagorean theorem. So a squared plus b squared equals c squared. So I'm looking for a squared, b is 18 squared, and c is 33 squared. And if I work that out, I will subtract a squared from both sides. So a squared will be 33 squared minus 18 squared, and I take the square root. And so a is the square root of 765. Now, you need to reduce the radical. We're going to write it in simplest radical form. So I'm not done yet. I have a little extra work to do. So 765, I would reduce that. That would be 5. And if I plug that in, that would be 1 and 3. And let's see here, 135. Is that right? Let me grab a calculator real fast. It just doesn't look right to me. 765 divided by 5 is 153. I had them backwards. 153. Okay, so 153. Don't know why I went red there. 153. 1, 5, and 3, if you add those up, they add up to 9, which is divisible by 3. So that means 153 is also divisible by 3. And we divide that by 3, we'll get 51. 51 is also divisible by 3. 17. And so now we have all the prime factors. And basically, if you have a pair of prime factors that are the same, you can bring those out. So the square root of 765, it will be 3 on the outside times the square root of 5 times 17. And 5 times 17 is 85. So my a up here is 3 times the square root of 85. And now I'll find my sine, cosine, and tangent. So the sine, cosine, and tangent part are not really the hardest parts. It's getting the sides that are it's sometimes the most difficult and lengthy part. So again, sine is opposite over, whoa, don't know how I got my triangle there. Let's try this again. Opposite over hypotenuse, opposite. So what's opposite A? 3 times the square root of 85 divided by the hypotenuse, which is 33. This fraction can be reduced. 3 over 33 is the same as 1 over 11. So square root of 85 over 11. Cosine is adjacent. So the side that's adjacent A is 18 divided by the hypotenuse would be 33. And you reduce, let's see here, 3 will go into both of those. Let's see, 3 will go into 18 6 times, and 3 will go into 33 11 times. So 6 over 11. And then finally, the tangent is opposite over adjacent. So the opposite side is 3 times the square root of 85. The adjacent side, is 18. And that will reduce to the square root of 85 over 6, because 3 will go into 3 one time, and 3 will go into 18 6 times. And there you go. That's the sine, cosine, and tangent of A. The reciprocal identities, I have a mistype on here. So if you're looking, if you have these notes at home, you need to fix it for me, because down here at cotangent, it is equal to 1 over tangent or the adjacent over the opposite. And I, for some reason, put adjacent over hypotenuse. Well, adjacent over hypotenuse is cosine, not cotangent. So let's fix that right quick here. That should say opposite. So adjacent over opposite is cotangent. Okay? So Cosecant is the reciprocal of sine. Now, why they didn't let the reciprocal of sine be cosine and the reciprocal of secant be cosecant, I don't know. It bothers me greatly. If you do know, drop me a comment. Let me know the purpose of this, because it's silly, unless there's a really good reason I just don't know about. So I love math, but I do not like this wording here. It seems to me it would have been made a lot more sense for sine's reciprocal to be cosine, secant's reciprocal to be cosecant, and tangent's reciprocal to be cotangent. Well, they got 1 out of 3. So for some reason, sine's reciprocal is cosecant, and secant's reciprocal is cosine, or cosine's reciprocal is secant, however you want to think about it. So reciprocal, if you remember, just means you're going to flip it. So if you know, it says if the cosine of theta equals 3/4, the secant is the reciprocal of cosine, so you just flip it. It would be 4/3. If you're doing example 4, they give us a decimal. Cosecant is the reciprocal of sine, so we're just going to say, hey, that's equal to 1/1.345. And if you wanted to put that in your calculator, you get a big long decimal that will round to 3 decimal places, would be 0.743. Your teacher or whoever will decide which way they want you to write your answer, okay? I will take either way. Example 5, now we're finding all 6 trig ratios. So now we're finding sine, cosine, tangent, cosecant, secant, and cotangent. So we're basically putting everything we've done so far together and doing it all at once. So really, all I'm going to do is find the first 3, and then I'm going to flip them. So I just realized that I don't have my hypotenuse here. Let me find out what it's supposed to be. Oh, I don't have my hypotenuse. I have this leg down here. This leg is also 7 centimeters. Sorry about that. So I need to find this side. So this angle is big M, so this side will be little m, okay? It is the hypotenuse, so I'm going to use my Pythagorean theorem. 7 squared plus 10 squared equals m squared in this case. Take the square root of both sides. That will be m is the square root of 149, which cannot be reduced. So we just leave it square root of 149. And we start doing our trig identities. So, or excuse me, our trig ratios. So the sine of p will equal, the cosine of p will equal, and the tangent of p will equal. Notice I do the first 3 first, and then I'm just going to flip them to get the reciprocals. So sine of p, again, opposite over hypotenuse. So the side that's opposite p is 7. The hypotenuse is square root of 149. Now, they don't like leaving square roots on the bottom. So the way we get rid of that, it's called rationalizing the denominator. We're going to multiply by the square root of 149 over the square root of 149. That will be 7 times the square root of 149 over just 149, because the square root of 149 times the square root of 149 is just 149. And that's all you have to do there, okay? If you notice, really all you're doing is you're going to bring the square root to the top and then take the square root off of the bottom, is basically if you want to make a little shortcut. Cosine of p is adjacent over hypotenuse. The adjacent side, I'll use a different color here, is 10. And the hypotenuse is still square root of 149. So 10 over the square root of 149. And like I said, if you want to do the shortcut, just move the square root of 149 to the top with the 10 and then write it over 149. And always reduce if you can, but we can't here. Tangent of p, opposite over adjacent. So opposite over adjacent. So opposite is 7. Opposite over adjacent, 7 over 10, which does not reduce. So you can leave it like that. And now you just do the other 3. So cosecant comes first, secant, and then cotangent is last. So for cosecant, I'm just going to look up here at sine, and right here is my answer. But all I have to do is flip that. But if I flip that, I will have the square root on the bottom, and I don't want the square root on the bottom. So what I'm going to do is flip my original answer right there, and that is perfectly fine. So that will be the square root of 149 over 7. I'm going to do the same thing for secant. I'm going to flip the original answer we had. That's going to be square root of 149 over 10. And the reciprocal of 7 over 10 for cotangent. Again, I'm looking at tangent here. It is 10 over 7. And there you go. You have all 6 of them. All right. Example 6, we talk about special right triangles. There are 2 special right triangles. One is a 30, 60, 90 triangle. One is a 45, 45, 90 triangle. Here is their relationships for the right triangle. Everything revolves around this short leg right here. Okay, the short leg is always opposite the 30 degrees. The hypotenuse is always 2 times the short leg, and the long leg is the short leg times the square root of 3 every single time. Okay, so see if I can move that up a little bit. Oh, whoa, I'm going crazy. Sorry about that. Never mind. I'll just continue drawing. All right, for my 45, 45, 90 triangle, well, if it's a 45, 45, 90, forgot to put my 45s in here, then the legs are equal. Okay, so this leg is the exact same thing as that leg. Okay, and then the hypotenuse is whatever the leg is times the square root of 3. Okay, so every time you can do this, you can use this on every one of these to fill out your chart here. There's also a way to do this using your hand, and I will post that video as well in your lesson here. The video I'll post will show you how to find 0, 30, 45, 60, and 90 just using your left hand. But I'm not going to put that here because I've tried to do it in class and it just got a little too confusing. So I'll post that separate on another video when you're looking at this. So look for that. All right. So sine of 30. I'm going to go back here. So sine of 30, what's opposite 30? X over the hypotenuse is 2x. The x's cancel. I'm left with 1/2. It is to your advantage if you just break down and just memorize this whole thing, because it will help you tremendously. 60. The opposite of 60 is x square root of 3 over 2x. Again, the x's cancel, so you have square root of 3 over 2. And then 45's sine, opposite of 45, it does not matter which one you pick. The opposite will be x over, the hypotenuse is x square root of 3. Well, that is 1 over the square root of 3. And just like earlier, we don't want our square root to be on the bottom, so you move it to the top and multiply it. So square root of 3 times 1 is square root of 3 over 3. That is your final answer. All right. For cosine of 30, you do adjacent over hypotenuse. So that will be x square root of 3 is the adjacent side to 30. The hypotenuse is 2x. The x's cancel, so you'll be left with square root of 3 over 2. The adjacent side to 60 is x over the hypotenuse is 2x. That is reduces to 1/2. Again, the x's just cancel out. 45, the cosine will be exactly the same thing as your sine because they're both, the opposite side and the adjacent side are both the same. So it will also be square root of 3 over 3. The tangent of 30, opposite, would be x over adjacent is x square root of 3. Again, those cancel each other. we're left with 1 over the square root of 3, which we've already reduced down here at 45, okay? So we've already reduced this particular one, so I know it's going to end up being square root of 3 over 3. Tangent of 60 would be opposite, will be x square root of 3 over x. Well, that just reduces to square root of 3. And then finally, the 45, the tangent would be x over x, which is equal to 1. And then for your cosecant, secant, and cotangent, you just flip all of them, okay? So for cosecant, I'm going to look over here at sine right here. And sine of 30 was 1/2, so the cosecant of 30 is 2. The cosine of 30 was square root of 3 over 2. So the secant of 30 will be 2 over the square root of 3. And we got to, again, rationalize that denominator. So just move it to the top. 2 square root of 3 over 3. Okay? And then tangent, we're going to look at, cotangent, we're going to look at tangent. The tangent was square root of 3 over 3, but I'm going to look at this part and flip that one. So it's just square root of 3 over 1, which is square root of 3. For cosecant of 60, I'll look at the sine of 60. I'm flipping it, so that will be 2 square root of 3. Again, move your square root of 3 to the top and take the square root off on the bottom. And there you go, you just simplified it. I know it looks more complicated, but you rationalized the denominator. You got rid of the denominator on the bottom. For secant, I'm going to look at cosine. So the cosine of 60 was 1/2. So the secant of 60 must be 2. And finally, the cotangent, I'm going to look at tangent. The cotangent will be 1 over the square root of 3, which we'll reduce to, move it to the top, take the square root off the bottom. And last but not least, 45. If you look at that part, I'm going to flip. The sine of 45 was 1 over square root of 3, so the cosecant of 45 is just square root of 3. That will be the same for the secant. And if you flip 1 for tangent, it stays 1 for your cotangent. Like I said, it will be beneficial to you if you remember and just memorize this box, or you can always use your triangles to figure them out. And like I said, there's also a way to use your hand. If you just look under hand trick under my channel, you should be able to find how to find the sine, cosine, tangent of 0, 30, 60, 45, and 90 degrees. Okay, our last example, cofunctions. It says, example 6. So basically, these are your cofunctions, right? This little section here. And you can use this up here to notice. All this is saying is, if let's say theta was 30 degrees, okay? So theta is 30 degrees. All this is saying is, hey, sine of theta is the same as cosine of 90 minus theta. So sine of 30 is the same as cosine of 90 minus 30. So if you did 90 minus 30, that would be 60. So basically it's saying the sine of 30 is the same as the cosine of 60. And if you look up here, the sine of 30 was 1/2, and the cosine of 60 is also 1/2, and it's true. And so that's all these are. If you can memorize them, that would be great. You do use them quite often. So I'm just going to use my box here. It says sine of theta is 0.5. So what is the value of the cosine of 90 minus theta? So I use the one we were looking at just then. It says they're equal. So the cosine of 90 degrees minus theta is just the same thing, 0.5. Okay. Hope this video helps. Take it in, do some practice problems, and let me know how you like it. As always, have a great day. Stay above the line, and we'll see you next time.